Hello everyone. With the information you're going to get in today's lesson, you will have every tool necessary to answer any of the vector problems we're going to come across. So let's start off by looking at the difference between yesterday's work and today's work. Yesterday's work, you were being asked to solve for one of the unknown sides to a triangle. Let's say like letter L right here. You didn't know what this value was. Well, in today's work, what we're going to do is we are going to solve for this value right here. What's the direction of the resultant vector? So, to start off, anytime that you have a vector diagram like this, you always have to look at where the angle is at. That is going to indicate your point of origin. So I know that that's the point of origin. That means that my resultant vector is going to look like this. So I'm going to put a little dashed line right here so that way I know that this is the angle that I'm going to be looking for. Now, that angle is made up of two component vectors. We have some movement that's to the west. We have some movement that's to the south. And we would describe this 10, let's say meters, we would describe that 10 meters at some angle pointing south of west. All right, now what we're going to do first is try to figure out which is the right formula to use in determining what that angle is. In order to do that, we have to label up the sides of our triangle. So if this is my angle, that means the 4 is the opposite side and the 10 is the hypotenuse. So my trigonomic functions up top, tangent, nope. Adjacent, that has, or a cosine has adjacent hypotenuse, no. Sine has opposite and a hypotenuse, so that's the one that I'm going to use. So we would have sine, and we're just going to put theta because we don't know what it is, equals opposite, that was 4, hypotenuse is 10. All right. In your calculator, if we divide this out, and I want to show you what you might tend to do at first. You might look at this and say, all right, well, 4 divided by 10 gets you a 0.4. Is that the angle that we're actually looking at? Does that look like a 0.4 degree angle to you? No. The 0.4 represents the trigonomic ratio for that particular angle. We don't want 0.4. We want what 0.4 represents. That's the angle. All right. So how do you put this into a calculator? Well, we want to use what's called the inverse sign. It's just the opposite of us trying to find the decimal value of the angle. We're trying to find the angle, so we have to go backwards now. To do that, we're going to use the shift button or the second button on your calculator. And you notice how it popped up and it now says sine -1. That's inverse sine. And this is the easy part. You have 4 divided by 10. We're going to close that. And now we get the angle for this particular resultant. This would be, if I erase my question mark, this would be a 23.6 degrees south of west direction. All right, now just to emphasize this, we're talking about if we are standing at our point of origin, we would have to go south from west 23.6 degrees before I would hit that resultant vector. That's what that means. All right. We're going to do a couple more of these. We have letter B. Letter B, it says that we have our angle right here at the bottom. So that means that this is my resultant vector right here. Okay. And to label my sides, I know that this is the adjacent side. This is the hypotenuse. So if we're to determine which formula we have to use for this, that tells me if I have the hypotenuse and adjacent side, that cosine is the correct formula. So I'll put some information down here. We're going to have cosine theta, because I don't know what that angle is, equals 3 divided by 8, the hypotenuse. All right, calculator. We are not finding the decimal value of the angle. We want to get the angle. So that means you're going to have to press the shift or second button, depending on your calculator. Cosine 3 divided by 8 equals. So this gets me an angle theta here is going to be, and let's put it right off to the side. We'll put meters, and this is going to be a 67 point, let's round that off. We'll just say a 68 degree angle. And if this is to the west, I would have to go north of west, that 68 degrees. So north of west, right there. Let's look at letter C. Letter C, our angle is down here. So that tells me my resultant is pointing in the northwest direction. All right. So labeling up my sides, I know that the 30 is the opposite side. The 40 is the hypotenuse. The formula that involves the opposite and hypotenuse, I have opposite here, hypotenuse here. So that means I'm using sine. I'll have sine theta equals, we'll have 30 divided by 40. And again, since we're trying to figure out what the actual angle is, we're going to have shift sine 30 divided by 40, close it up, 48.6 degree angle. So we'll have 40 meters walked. We're always going to use meters for this. So we have 48.6 degrees. And if this is to the west, I would need to go north of west to get to that, north of west. Let's go to question E here. Question E, my angle is down here, so that means the resultant is pointing to the northeast like this. All right, labeling up the sides, the 30 is the adjacent, the 40 has to be the hypotenuse. So, which one of these has adjacent and hypotenuse? Cosine does. We'll have cosine, we'll put this down here, we'll have cosine theta equals 30 divided by 40. And we're not trying to find the decimal value, we're trying to find the angle. So shift cosine 30 divided by 40, close it up. You get an angle of, and we're going to put that right up here so that way we have it on the right thing. This is going to be 41.4 degrees. Now our direction, if this is north, I'd have to go east of north to get to it. So east of north. We'll do letter F. Letter F, we have our angle here. So this is the resultant. Okay. The 9 would be the opposite side. The 12 would be the hypotenuse. So which formula has all of those pieces to the puzzle? We have opposite, hypotenuse. Sine is the one we're needing to use. So we have sine theta equals, opposite is 9 divided by 12. Trying to find the decimal, not the decimal value, we're trying to find the angle. So we'll have inverse sine. We'll go 9 divided by 12, close it up. We get 12 meters with an angle of 48.6 degrees. And this one, if we're describing this, this is to the south, so this would be east of south. We have letter G. Letter G, my angle is up at the top right here. So this is my resultant. Okay. Now, labeling our sides, we have the adjacent, we have the hypotenuse. So, which trigonomic function are we going to use for this one? Well, adjacent and hypotenuse, we have right here cosine. So we'll have cosine theta equals, the adjacent side was 2, the hypotenuse is 3. So since we're trying to find the angle, I have shift, so that brings up inverse cosine. We'll have 2 divided by 3, enter. So that angle right there, this is going to be a little ugly because of the placement of this. We're going to have 48.2 degrees. And here, if this is to the south, I'd have to go west of south to get to it. I'm going to do one more, and then you're going to have to do the rest on your own. So we have letter H. Letter H here. You've got your resultant vector is right here. That means the 40 is the hypotenuse, and then the 8 is going to be the adjacent side. When we work this out, that means from our list of trigonomic formulas here, we're going to have to use adjacent hypotenuse. We've got another one that's using cosine. So we'll have cosine theta equals 8 divided by 40. So we'll clear this off. We have inverse cosine, 8 divided by 40. Close it. You've got an angle that would be 78.5 degrees. And with this one, we don't really know what our original angle like here or here was. So we're just going to leave it as 78.5 degrees. And we'll put, we'll just leave it as that because we don't really know. We know that it's to the southeast some way, but we don't know what these two values are right here, so we're not able to really identify a true south of east or east of south for that, okay? So just understand that that one's going to be off just a little bit. What I'd like to do is see if there's one. Yeah, let's do one last one just because we haven't done anything with tangent yet. So let's do one with tangent just to make sure that we hit on each one of the different trigonomic functions. So if this is my angle here, and this is my resultant, it's always the hypotenuse, right? The 1.5 is the opposite side. The 0.6 is the adjacent side. So I've already kind of led this to you that if we're looking at opposite and adjacent, that means we're using tangent. So for this particular one, we're going to have tangent theta equals 1.5 divided by 0.6. So we'll clear that off on the calculator. Inverse tangent, 1.5 divided by 0.6 equals, that would be a 68.2 degree angle. And if this is to the west, this would have to be north of west to get to it. All right, it wasn't asking for the magnitude of that resultant vector. We could use the Pythagorean theorem if we'd want to, but it didn't ask us, so we're not going to worry about it. What you have to do now is any of the remaining ones on the paper. Okay, you've got, let's see, you have 1, 2, 3, 4, 5, 6, 7, 8, and then we didn't do letter D at the top. So you have those to do for tonight. When you're finished with it, go ahead and take good pictures of it, submit them to Schoology, and you're all set.